So in part B3, they try to give you much more information and 3 more points. First, they say that the shortest distance from origin O to the line passing through G and M. Line passing through G and M is this dotted line. And then don't forget it, this is the midpoint of the chord. So this line and the chord should be perpendicular. This is the first thing. Second thing, they say that origin O to this line, the distance is 2 square root 41. If you still remember the distance between point to a line, that means the perpendicular distance. So they just use very stupid way to tell you that OM, from O to M, the distance is 2 square root 41. So how can you solve OM, that means the distance, in terms of K? You can form an equation, the distance formula. You already know the x coordinate of M. X coordinate, which is 3k plus 14 over k squared plus 1. And then you can use the similar method on this straight line, y equal kx. So this is k times 3k plus 14 over k squared plus 1. We have this coordinate. X squared plus y squared is equal to the distance 2 square root 41. So we can build up the equation. Now we are going to do so. So M, we already know that 3k plus 14 over k squared plus 1. Because M is lying on this straight line y equal kx, so this is k times 3k plus 14 k squared plus 1. And then compare with O. O, that means 0, 0. Since given OM is equal to 2 square root 41, they do not directly tell you, but they imply that. So this square plus this square, 3k plus 14 over k squared plus 1 square. Is equal to this square. So this is 4 times 41. Of course, you're not that stupid to expand everything in order to get maybe something like k power 4, something like that. You're not going to do so. So because this part is the same, so I keep it like this first. And then plus k squared. So extract the same thing, 3k plus 14 over k squared plus 1. And then this is 1 plus k squared. So you'll find that 1 plus k squared and the denominator are very similar. So we simplify it. 3k plus 14 bracket square is left, but however the denominator cancel out 1 bracket, only k squared plus 1. So 164. Very close, 9k squared and then plus 6 times 14, 84. So move everything is 155k squared. Use formula 1. So 0.8, so k is equal to 455, or k is equal to negative 8 over 31. It's quite good looking, so let's see, but we have 2 choices, so we better check again which one, anyone we need to reject it. We find that k is positive, so this is rejected, and then we know k is equal to 455. At this moment, even you don't know how to finish the rest, but at least you get some method mark, even though it's not easy. So just now the questions is here. We already know that k is 455. That means you can get the exact position of M here. We may do it later on. And then what they say is denote the location of P by a point A. That means P will move to a point at A when P is the farthest from M. So you find a point on this circle which is the farthest away from this point M. Of course, it's exactly opposite here. Of course, even if you have no idea what to do, then you should find out the position of A first. How you can find it out? You have the exact coordinate of M already by substituting K. So maybe we do it first. So M 3.0.8 plus 14 and then 0.8 squared plus 1. This is 0.8 times this. Wait, 10. This is 10. So this is 8. We got 10 and 8 here. Oh, the line is not below the center, but it should be above the center, but it doesn't matter. So we already know this is 10 and 8. How can we get this line? First, we have our slope mg, that means ma, passing through here. So we may use the simultaneous equation to find out the coordinate of A. After that, they say that denote point B when P is nearest to y-axis. This is 14. The height here is 3. That's why the circle should be like this. And then the nearest, it seems like you're shifting the axis. So this point, you can directly find out that means 14 go back 10. The radius is 10. 14 go back 10. So this is 4. You can find out B directly, which is 4, 3. So after that, how can you solve the questions? They say that U is a point below the x-axis, and then such that the area of the circle passing through AB is the least. In order to do so, basically it's based on some assumption. If you consider a circle passing through A and B, and it should be the smallest, how you can draw the circle? It's not exactly the same circle here because we have some new limitation. Pass through A and B and U. U is somewhere below x-axis, so we don't need to care about that. If you consider the smallest circle, can be maybe like this, maybe like this. The smallest circle, the radius should be as small as possible. So, in the smallest case, AB is the diameter. They say that the least area case, that means imply AB is diameter. Now, how can we prove that is M together will form a concyclic? If AB is diameter, or AB here, any point U will form right angle. So you can easily test. The key point is, how about M? If M is somewhere here, you want to know that whether it's concyclic or something like this, then you just need to check the slope AM times BM. See whether it is right angle or not. If it is right angle, that means they are concyclic. If it is not right angle, the product is not -1, then that means it is not concyclic. We use this method to prove. So that's how you finish this question. This part I leave it to the audience because it's quite troublesome. You need to draw equation of straight line, solve the simultaneous equation. So leave it as yours to you.